rectangular pulse. So the shape of the signal you see, so the shape of the signal is like a rectangular. Okay, that's why the name is called as rectangular pulse. Okay, so you see the graph. So from the graph, so you see for the time, some minus t by 2 to t by 2, the signal is having amplitude. The signal is having constant amplitude A. Okay, for the remaining time, okay, for this minus infinity to minus t by 2, t by 2 to infinity, the signal is having not at all amplitude. Okay, so that's why this signal is called as gate function or rectangular pulse. Okay, so what is the standard notation of this rectangular pulse means a rect of t by t. Okay, this is the notation. That is the sine waveform is noted as sine omega t. Okay, similarly the rectangular pulse is noted as rect of t by t. Okay, a is said to be the amplitude of the rectangular pulse, and t divided by t is a variable time. Okay, divided by the capital T. What is the capital T means? It is the width of the rectangular pulse. Okay, you see. So in this pulse, what is width? The width is said to be the difference between this upper limit and this lower limit. So t by 2 minus of minus t by 2. So what is the width of the signal? It is t. So that t is called as the capital T. Okay. So a rect of t by t, it can be defined as, so for the time t, small t is from minus t by 2 to t by 2, the signal is having the constant amplitude A. For the remaining time, the signal is having zero amplitude. So this is the mathematical notation of this rectangular signal. Okay, rectangular signal. So in the paper, the signals and system paper, in full and full paper, we are going to use these standard signals. So for these standard signals, we are going to apply Fourier transform, Laplace transform, and anything. Okay, so we are going to calculate it is a periodic signal or not. Okay, so in all problem, these standard signals we are going to see. Okay, that's why first you should understand what is that standard signal, what is the nature of that standard signal, you should understand. Okay, that is the thing. So this is the rectangular pulse. Okay, similarly this is a discrete rectangular pulse. Okay, so this one is a continuous rectangular signal, this is a discrete rectangular signal. About how to derive the rectangular signal, so rect of n. Okay, instead of the small t we have to put n, but this signal is having, you see, so the rectangular signal is having some constant amplitude 1 for the time minus n to plus n. Okay, so that is below the minus n and above plus n, the signal is having not at all having any amplitude. Okay, so by how to define this rectangular pulse? So the rectangular pulse rect of n is equal to 1. Okay, n is equal to 1 for the small n. Small n is a variable, capital N is a constant. So the small n is from minus n to n, 0 otherwise. Okay, so it can be also denoted as rect of n is equal to 1 for modulus of n is less than or equal to n. Okay, this is the discrete time rectangular pulse. Okay, and the next function, it is a signum function. Okay, signum function. The signum function, it is denoted as sgn of t. Okay, not capital T, it's a small t. Okay, signum of t. So you see the shape of the signum signal. So what is the shape of the signum signal? You see, for the time t from 0 to positive time, the signal is having plus 1 amplitude. For the time minus infinity to 0, the signal is having negative minus 1 amplitude. So this signal is called as, that is at a time t equal to 0, the transition occurred from minus 1 to plus 1. This is called as the signum function. So by the signum of t, it is defined as, it is plus 1 for t greater than 0. It is minus 1 for time t less than 0. At a time t equal to 0, there is a transition is occurring. Okay, transition from minus 1 to plus 1 is occurring. It is a continuous signum function. So the discrete signum function, it can be defined as, instead of this small t, we have to put n. So the signum of n is equal to 1 for n greater than 0, minus 1 for n is less than 0. So this is the signum function. Okay, so this is one of the standard signal used in our field. Okay, then the last one is a sinc function. Okay, so what is the sinc function means? You see the shape of the sinc function. So the shape of the sinc function is, this is like a sinusoidal waveform, but the amplitude of the sinusoidal waveform is in center time. the waveform is having maximum amplitude. Whenever the time increasing, or here in negative the time increasing, the signal is having amplitude, it is amplitude reduces, correct? So in the center the signal is having maximum amplitude. Whenever the time increases from this origin, the amplitude of the sinusoidal waveform is decreasing. So this is a one type of standard signal. This signal is called as sinc function. So the notation of the sinc function is sinc, okay, S-I-N-C, sinc of t. Okay, so what is a mathematical expression for the sinc of t? Means the sinc of t is equal to sine pi t divided by pi t. The ratio of sine pi t divided by pi t, we are calling it as a sinc t. And that is, we can describe this sinc function. So the sinc function is having the maximum value 1 at a time t equal to 0. You see the graph? At a time t equal to 0, the signal is having the maximum amplitude 1. Okay, so sinc of 0 is always 1. Okay, and the sinc of t equal to 0 at a time t equal to plus or minus 1, plus or minus 2, and plus or minus 3. That is, you see, whenever this graph, that is where the graph it will cut in our reference line. Okay, this point. Okay, at a time t equal to 1, this graph it reaches the amplitude 0. Similarly, the time t is minus 1, it reaches the minus 1, the signal is having amplitude 0. Similarly, at a time t equal to 2, at a t equal to minus 2, 3, minus 3, and 4, minus 4, the signal. So these are all the standard signals used in our communication field. Okay, so what are the standard signals we studied? That is, the first one is the first signal is a unit step signal. Okay, unit step signal. Then the second one is unit impulse signal. Then the third one is a unit ramp signal, and the fourth one is a sinusoidal signal. Then fifth one is a exponential signal. Then rectangular pulse. After that, a signum function and a sinc function. Okay.